Hi guys, today we're going to keep working on circular motion. In our previous lesson, we started working on circular motion and we've covered quite a whole lot on it up to this very moment. So today we are looking at centripetal force and period. So when we talk about centripetal force, what are centripetal force? Don't forget centripetal force is same thing as angular force. Let me use that word. Now let's see what centripetal force is. When we talk about centripetal force right here, let's say we have a uniform circular motion right here. That's from the center. And then we have a bulb here. At this point, you know what it is. At point A, at point B, we've discussed all this already. There's a velocity at point A, and there's another velocity at point B. While we have what we call the angular velocity. These two velocities here, we'll call them linear or tangential velocity. So when we talk about centripetal force, don't forget what force is. What is force? Force is simply mass times acceleration. But this time around, we're not talking about just ordinary acceleration. We're not talking about linear acceleration. We're talking about angular acceleration, or I can call it centripetal acceleration. So centripetal force is simply mass times angular acceleration. You can write it like this, or we can write it as centripetal acceleration. It's the same thing. Mass times angular acceleration, or mass times centripetal acceleration. So what's the centripetal force? Now, centripetal force is simply that very force that helps bodies to maintain movement in a circular path. Now, without the centripetal force, there is no way we're going to be discussing circular motion. Circular motion is circular motion because of centripetal force. Without centripetal force, that is the force that helps different kinds of body to maintain circular motion. Now, for example, when we talk about planetary bodies, like let's say the Earth, orbiting the sun and the rest, is gravitational force that helps us, that brings about the centripetal force. So different factors or different things bring about centripetal force. So don't forget, centripetal force is simply the force that helps body to continue in that circular path. Now, if you look at this body at junction A, at this very point, if not for the centripetal force, that is the mass of this very body and acceleration, centripetal acceleration, this body would have probably moved out like this. But okay, let's say this body was, let's say the string, this very string here, was caught at this very junction. As the body moves like this, if this string is caught at this very junction, this very ball will project down like this. But thanks to centripetal force that was made available by the help of this, let's say this very string, that helps this body to keep moving like this. So different things brings about centripetal force. For a pendulum is a string. When we talk about planetary bodies, is the gravitational force. Now, let's say a car moving on the road. For a car moving on the road is, let's say, a car moving on the circular path. A plain circular path is the friction in the tires of the car that brings about centripetal force. Now, different thing, you're going to be looking at that in the next couple of lessons. You're going to see things that bring about centripetal force while we derive more formulas. So now, don't forget, centripetal force is simply the force that helps a body to maintain movement in a circular path. So quickly, there's it here. You're trying to derive the formula. Don't forget, angular acceleration, or centripetal acceleration, is equals to velocity squared over radius. We derived this in our previous lesson. So centripetal force, I can say Fc, centripetal force is equals to mass times this over this. This here is linear speed or linear velocity over radius. So the centripetal force is mv squared over radius. This is centripetal force here. So as easy as ABC. Now don't forget angular acceleration has other formulas. We can try to be creative with this very formula. We can come up with other things, for angular acceleration. So centripetal force is simply mass times angular acceleration. So that's just that. So quickly, let's look at period. Now, when we talk about period, what is period? Now, period is a nested. Period is simply the time it takes a given body moving in a circular path or in a simple harmonic path to complete a given number of cycles. Now, let's say this body is here. Now, this body will move, let's say, from this very junction. It covers, it goes like this. Then it comes back to this place. That is one cycle. It does it again, 2 cycles, and so on and so forth. So period is simply the time it takes a given body moving in a circular path to complete a given number of cycles. So period is simply time over number of cycles. But we're not really talking about this today. I'm just trying to use this to explain the basic meaning of period. So when we talk about period, we're going to relate period with angular velocity. Angular velocity that was derived, we said it in our previous class, that angular velocity is angular distance or angular displacement over time taken. But there's another formula for angular velocity, which is 2 times pi times frequency. Now, frequency is simply the inverse of period. That's period, that's 1 over period. That's a frequency. So angular velocity is 2 pi times 1 over period. That's what angular velocity is. So if angular velocity is 2 pi over t, so it means the period itself is 2 pi over angular velocity. Percent time over number of oscillations. Don't forget, so period is more or less like how long it's going to take a given body to complete a given number of cycles. So it could take 2 seconds for a body to complete 2 cycles. It depends. So when we talk about period, the unit for period, is we can say seconds also. So that's that for everything on centripetal force and period. Don't forget, centripetal force is simply the force that helps a body to keep moving in a circular path. Without centripetal force, there won't be anything like circular motion. For centripetal force, most bodies would have jumped out at different edges, at different junctions. But centripetal force keeps them in check or keeps them moving in that circular path. So at the very point in time, we're drawing the curtain on this very lesson. So in the next set of lessons, you're going to be deriving complex formulas, because these two formulas are the last set of formulas for basic formulas under circular motion. So if you love this very lesson, subscribe to the very channel, Edge Mosaic, and also share this lesson with others. Follow me also on Facebook at Revelation Up. See you in the next lesson. Thanks.